Hi YouTube, AC Dodd here again, and welcome to the second part of the battery build. I'm not going to waste your time, let's get on with it. Okay, just an upfront warning here. This video is about building a lithium ion battery pack. Obviously, this video is provided for information and entertainment. If you do decide to do what's in this video, then you very much do that at your own risk. I can't be held responsible for your lack of competence or any corners that you might cut. So, with that in mind, let's get stuck in. So, what I've done here is I've got the battery case. Okay, that comes apart so we can put the cells in a little while. But what I've done is, how do we know where to assemble this and where's positive and negative, and how does it, which way do the cells go in? Well, there's quite an easy way to remember on these. So the way I like to do it is I get the BMS battery board, put that on, and bearing in mind this only fits in one way because it has 2 pins at the top, one there. I'll use something else to point with, one there and one there. And it also has 2 holes and 2 screws to hold it down. So you've got one there and you've got one there. So basically, if you fit that in the right place, like so, the way these are positioned is, once the board's on, the positive battery terminal is this end, and the negative battery terminal is this end. So we're going to put our cells in, and then we'll put positive, negative, all the way down, and then they're nice and ready to connect up. Okay, so now we need to choose our cells. This is my little one of my storage cases, and I'll keep the cells inside. So what we're going to do is just go around and find some cells that are all around the same capacity. As you can see, those 2 aren't straight off the bat. So we'll select 15 cells that are close in capacity, but also are close in internal resistance. So with our cells out on the bench, unsorted, just check them. 32.9, 33, 4.16 volts. So you just check to make sure the internal resistance is about the same, very close, and that the charge levels are all the same. As you can see, these are basically fully charged, and they've been left sitting for about a month. So they, as you can see, they've not discharged, which is really good. I'm not going to do all of them on camera anyway, but I have done them all, but they're all basically the same. So we're going to put those in. There are our cells. Now we want to take our cells and we want to load our battery pack. Now, 3 rows. So take 1 from each pile and simply stack them up like so. 1 from each pile, and then on the next row, up the other way. 1 from each pile. And the reason why I'm doing 1 from each pile is because what I've also done is I've evened up the milliamp hours amongst these cells. So the idea there is that we end up with an even amount of capacity on each of the 3 legs. So with the cells in, that's what you should have: positive, negative, positive, negative, positive. Okay, and then you can put the cover on. But before I do that, what I like to do is just rotate the cells, because this makes it easier, as you'll see when we come to assembling, and where all these cells have been previously used and the tabs have been taken off. If you turn all the cells round so all the tabs are basically parallel, it's a lot easier for when it comes to welding the new tabs into position from the new nickel strip. So with the cells positioned nicely, we can put the top on. Bit of a jiggle and down it goes. And the idea there is that keeps all the cells together. So what we can now do is screw these two halves together via fitting the screws into the slots provided. Sometimes easier with a drill. In this case, I'm just using a Milwaukee M12 screwdriver, and I've got it on the very lowest setting. So the idea is we don't strip any of those screws out in the plastic. Like so. And we go down and we fit every single one. Now, one of the things we have to be very careful of is I'm actually building this with fully charged cells. Not recommended if you haven't done it before, because if you short something out, this can get very, very exciting very, very quickly. So in this case, don't do what I do, but you should do these with cells that are pretty low, so they haven't got enough energy within should you cause a short to cause a problem. So in this case, let's carry on. Okay, so with the batteries in place screwed together, we can start fitting the nickel strip. Just make sure it goes over all the little pinholes and clips it in place, including the ones on the top. And then the strip and the dimples are in place over the battery. And then you can take your means of connecting. And in this case, I'm going to use a spot welder, and we'll spot weld all those into position. So I'm just using my standard spot welder, in this case foot operated. We'll just go through and we will connect those up. And you can see with a spot welder, this is a very quick activity. There we go. That's those cells in. And then obviously what I'll do is I'll just use a screwdriver and very carefully just check my progress on there to make sure the settings are right and they're actually welding properly. Okay, so all the spot welding's done. As you can see, it looks quite professional using a proper battery pack like this one. Keeps everything looking nice. I've been around and give those a quick tweak, which is why you can see some bends on some of those, because I was just making sure that they wouldn't come off. Just worth noting that I had to use full power on my spot welder to get good joints on that. Okay, so the next thing we need to do is get our BMS board and get that connected on. And that's just a case of lining up the holes and lining up all those tabs, yeah, with the circuit board. If you don't, you'll end up bending and breaking them, so be careful when you put the two together. So on this particular BMS board, some boards have a metal tab here and another one here, so that you can connect those to the connections on your pack. In this case, it doesn't. So, and that's interesting because the other battery pack that I bought, the empty shell that I bought, because I bought two at a time, did have, whereas this one isn't. So it just gives you some an idea sometimes the inconsistency. So what they've done in this pack is they've given you some wires, so they just simply go up into the board like so, and then they need to be soldered in position, and then these make the connections to the rest of the pack. And there's one of those for the positive, and there's one of those for the negative as well. So let's get that done. A little bit of solder, bring the iron in. Like so. Done. Now we'll do the other one. like so. So place the circuit board down on top. See the positive there and the negative there. They're not connected up yet. So what we've got to do before we do anything else is get this circuit board screwed down. So that screw there, tighten it in, put the small one in that little hole there, and then we'll get that tied down, and then we can actually start connecting this thing up. When you come to put this one in the circuit board, bearing in mind, don't drop the screw on the circuit board because you could short the connections. So with the board screwed down, we've got a number of connections to do. So we've got to connect that one, and then we've got one there and one there to solder on. And then we got the major board connections to make, which are those ones there. And in order to make those, they need to be, we need to tin the nickel strip. So let's get that done. What we don't want to do is have the soldering iron on the pack for any longer than necessary. There we go, nice and quick. Turn it round, and we do the one under that, like so. And now we've got something to solder to. So what we're going to do now is the small connections. I'll just zoom in a little bit so you can see what I'm doing. There we go. So let's just go through and make these connections. Excellent. Okay, so now we're going to make that permanent connection. I'll just put a little bit of solder on the end of my iron, and then I'll use a screwdriver to hold it down. So that melts on, and that's held down. Beautiful. One connection, turn it around, do exactly the same for that positive connection. A little bit more solder on the iron, screwdriver in place, melt it down, let it set, job done. That way, what you don't do is overheat the plastic underneath and then ruin the actual pack. So with it all connected up now, let's push the magic button, and we've got 4 lights, which indicates, that's telling us that that pack is fully charged, which it is. So that's good news. So let's see if it actually works. So we'll get this battery, connect a light to it, and hey presto, the M18 light works a treat. Wonderful. That means we can finish off the battery pack. Okay, so as before we finally button this up, a couple of things we've got to do. We need to take off any excess flux as best we can. So I'll just use a little tissue with some thinners to do that, and I'll do the best I can with all those other joints. The other thing we need to do is the little thermistor, which is that little black blob there. We need to push that into and in contact with the battery. I don't use any potting compound myself, but I'll just put it in close contact. As ever, I don't expect these batteries to get warm in service, and I will keep an eye on it when I use them anyway. If I find them becoming warm in the low current use that I'm using it, then clearly I'll investigate. So we'll take the pack, now that I've cleaned up the connections, and we'll put it in its housing and get it all screwed in. Just one quick thing to mention when you're buying these empty shell cases so you can build your own batteries. The more expensive ones, the BMS is much fuller. So there's a lot more components on these boards. So clearly, I don't know what the difference is because I'm not an electronics engineer. But the very fact these have got more parts on means there's probably more monitoring and a little bit more intelligence going on than on some of the cheaper boards. So again, when you buy these from AliExpress, you know, don't be tempted by the cheaper ones. Look for the ones that have the most components on the board as a good guide to go by. The kit also comes with this little thermal cover, so we're going to put that on like so. Take off the excess, and then that just fits over that hole like that, and then just covers up the connection and protects it and anything else that might come in the way of it. So take the top off, simply lower it on nice and evenly, push it down, and then all you need to do is put your screws in and we're ready to go. So your battery pack's now assembled. A couple of electrical tests just to make sure it's all there. We'll check the terminal voltage and we'll also check the internal resistance. So with those on there, we can see we got 65 milliohms and 20.82. That's an excellent reading. So battery's looking good. Push the tester on the front. We get 4 bars. Wonderful. So let's get some stickers on the side to identify it. And then she's ready to press into service. There we are, already all done. So we've got low demand, high capacity, got my initials on it so I can identify it. And then obviously the date it was built, which was today, and the internal resistance. Push the button and we're all good to go. So that will now be pressed into service. So let's go test it on what I'm going to use it for, which is the Milwaukee fan. So let's test it out. There's our new pack. Put it in, turn her on, speed 1, speed 2, speed 3. Awesome. Well, hope you enjoyed that battery build. You'll have to decide yourself whether it's worth it or not doing it. As I say, I built 2 of these, £38 each. So absolute bargain considering that they'll do almost, I should imagine, nearly 500 cycles. So as I say, if you can get hold of the cells at the right price, being about £1 each from salvaged sellers, then this makes a good opportunity. Clearly, if you're using worn out cells, then maybe not. But certainly in my case, those cells are rated at 3,200 milliamps, and they've all come in over 3,000 milliamp hours under test. So I'm very happy with the purchase I made there. It just goes to show that actually, if you look at the loads that you're actually trying to run, you can actually have a different alternative in terms of a cell, and it doesn't need to be one that's got a dubious background. As I say, I'm using the LG1 MH1s. They're going to give me great service. Anyway, as ever, please like and subscribe, and I hope you found this useful. Thank you very much.